all the widgets, everything. So it's okay, or you are same momentum you are maintaining the day one, like that. Day one only, like day one only. Yes, very nice. Yeah. So almost as said, Siri said like almost we are coming to the one more day to go. So you are I think now onwards like everything like a concluding type of things one by one aspect. And then tomorrow everything will all the session will continue here only. So just we have the main important thing as Sridhar mentioned like a, so we are all told, we are explaining almost and we are concluding tomorrow one by one. So you have to come with the, you can say one is like a feedback like what exactly the way you want the things whether they are not, that's one thing. And main like a questions like a, from whatever you understood how you plan your research, how you plan your like a projects related to your either your MSc projects or whether your research work or in when your organization how you plan your works. All things we can come there, we are there. See there is a exclusively keeping some time for to get all the things, and we will take some questions like how really you can take further your research work. That's what is our main intention, that whatever you learned here that has to be useful for you once you go back to your place. So with that just before going to the today's class, like it is all like some of the things like instrumentation. So as we are discussing the other aspects, right, today everything like a modeling and then simulations and all the things, right. What is the basic ingredient for all those things? Data. So for data, so what is the main source? So instrumentation. So unless there is no, you can say the, you see other day you saw like how much you can say the things are going when you see the instrumentation in the water, or you can say basins, or you can say watersheds we can say. So here today we will see like a what is the like a, as you already some of those things already you come across in the lab, like you are already saw in the field, and some yesterday I think Sridhar is already gave a brief like connected whatever that saw you in the field, and then how those things will be connected as a data sets you saw already. So I will little back like instrument side only, just we see some instruments what are there and what are the changes are occurring, and one new concept that like there is something called open hardware actually. So like nowadays like open software is there, right, like that open hardware is there, but that really how that really make a sense in this I can say the simulating or understanding sensing some hydrological process. So those things just I will introduce, and with that I will stop. So here this all comes under the one main important concept like a right now all this instrumentation and related works, this comes under the field hydrology. Okay. Now you most of the things like hydrology all things you studied, right. This is like a one specific we can say the one subdomain type of thing called field hydrology, where all these issues like what type of instrument has to be used for what measurements, how they have to be maintained, what are their specifications, how their calibration. So all things comes into this one, and of course general techniques, and then of course this is what I am saying. So you will see one by one quickly. So this is the like a main thing here, like we are using the you can say field based observations, so understanding the hydrological process. Okay. So this is the initial like a one stage, this is the one of the main thing. So all the process they are observing the in the field and then studying the hydrological process. Later they are evaluating data sets, later we develop models, and then later we shift it to the all modeling type of things. So but this is the main core thing actually. So it is like only measuring, and of course involve all the things. Okay. So now the you can say things like a whatever the you can say point observation, now the shift is from point observation to the spatial like aerial observations, like what the NISAR mission or otherwise previous like a microwave or soil moisture. Now field point to aerial thing. Only thing is of course we need to have proper calibration things. So this will all provide a lot of we can say the things it is useful for spatio-temporal quantification, it is useful those things. Okay, this is all like a lot of we can say things. So the main thing like all of you last 3-4 days we are discussing about all these things are connected to this thing. So their effort like other day like mentioning, right, whatever they do like what some graph or some data and making in the notebook those things, finally they will help you to do a very good calibration validation that we will rely on our results. Okay. So it is like a I said like a forecasting, this instrumentation is will make a one of the important things. So otherwise you can't verify, right, how much is with the forecast correct or not. Okay. So this will the I can say the whatever the advanced now with this thing, right, a lot of things we can do with the current like a we are yesterday we are discussing about some machine learning those things, right. We have some field data is there, With that we can take as input and we can do lot things. That's why things we are working. So that also I will just tell you briefly. So here it is also very much important in the integrated water resource management. That's what I think Siddhar also explaining something like AWRM, integrated water resource management. So a lot of instrumentation is there that you will get each and every parameter, accordingly you plan your water resource available, water resource, and then you can work. Okay. So it is all like a lot of, we can say, the connected things. Once we have the one data set means it will create so many quantitative, so many things we can do. So it is like a type of, we can say, things like a from starting any simulation to decision making to conflict resolution. Like a, for example, two interstate problems are coming, where they will check how much data really available water. So they say some many TMC, they say some state so much TMC. How we can that resolve actually? So once again they are saying with this field means like a measurements only. They call telemetry. They will go on measure the for the years. Accordingly they will decide how much water each has to be shared. So these are all the things actually. But now like everybody like making lot of things related to the model, like say modeling thing actually. But not things can be done at the data collection also. Lot of, we can say, developing a new sensing techniques, developing new field observations, data, you can see spatial temporal observations. That is one of the area actually. Lot of things can be done in that particular thing. So here, so all the instrumentation if you keep, so what is the fundamental basis actually? That is watershed. So you remember other day is showing that he put instrument, somebody asking like why it is there only, and how that has to be kept and how it will be decided where to keep the instrument. So like other thing like a other type of, we can say like a roads, other thing, that is a different way of sensing, right? For us is like anything we want to sense means, especially we want to measure something, you need to find some correct location. So or like whatever you measure, like how that we can say the quantification those things will be connected is as a the fundamental unit for us is the watershed. So you keep a rain gauge station, you keep a like whatever the you can see the water level recorder. So they are like you have to see where the what is the outlet, how much catchment area it is serving. So those all things you need to know those things, or you need to plan instrumentation watershed like that. So that's a thing, since that is like a scientific unit to do all the later simulations all things, that's why we need to give the instrument also like that. So it is like a, you can do the something like a basin level, right? So many instruments we are seeing, right? So some people like asking like a basin is there, like I am working in some other place in where the data is not there, then how we can work there, or you want to make a say different type of experiment you want to carry out. So for that normally the people can do this is called actually the experimental watersheds. So many places like some universities, so they will run this one. So experimental watershed, even the National Institute of Hydrology. So even the like we have some of things organization I will show you, they will have the separate thing, they will do entire instrumentation they will keep there, that as a model basin. So for all checking your models, for example HHMS, across or something other models you are developing, right, you can check there all those models. Okay, they are called as experimental basins. So now all those things are like maintained by, now for our Indian case means we have the CWC, they are doing all things, or any some of the institutes. So they will keep the experimental basin to keep all things. Every instrumentation they can we can see in that particular experimental watersheds. Okay, so normally each river basin they will have some at least one or two experimental basins to have all the data sets. Okay, so they will act as a representative things to keep all those data sets. That's like we can easily the surrogate basin, like we can test there and we can transfer data. Other day some people asking like how we can data transfer to from one small basin to a big basin. So once you can able to set model means same similar physiographic parameters are there, right? Same you can say the geological test is there and topographical thing is there, we can easily change the parameters. Okay, so these are the, you can say all the instruments already just like you are seeing. So if I say in the basin, you tell me the what type of, you can say the process will be there and the instruments will be there. These are all things same thing like a 5, 6 I kept here. So you can just quickly you can tell me, most of you know at least one way or other like what type of instruments you are going to use. So rainfall means rain gauge, we have the latest thing is the automatic rain gauge stations, automatic weather station they call. You can get rain along with so many 5, 6 parameters you will get. Then go for the stream flow. So already you saw thing, but there you don't have the only the physical measurement they are doing, but more accurate measurements means they are using current meter you are seeing, right? Those things already you are seeing, right? These are all already there, yesterday you saw that one. So next level means advancement to this one is, so ADCP, so acoustic Doppler current you can say profiler. So that will give the exact like a depth, especially big basins, right. So there you can't work with these things, current meter you can't keep on and you can't try, right. So there the ADCP will work, okay. So that is the you can say the instrument. So then you tell me about evapotranspiration. So nowadays like a flux towers we are one of the things, and eddy you can say eddy current meters will be there, especially the eddy towers, that is different actually. So those things, and then we will have the so flux tower, that is the latest one. Otherwise we have the old our standard Indian this thing means yeah sorry. So that is so these are some of the things are available. You can this is like a traditional you can say the class A pan this thing. So any you can say the basin you see that will be there, that is a standard one. But now lot of we can shift is there. Now actually satellite, that's where we can get the data set. Okay. So evapotranspiration estimation by satellite data set, that is there one research area. So where you can say lot of you can say data sets. Other day I am showing about that MODIS data sets. So there you can get the data, and then from there you do some equations, you can get into the evapotranspiration. So that is the that will have a lot of you can say thing, but all the of course field checking all things we can do with the things. So of course groundwater. So the mainly groundwater means the two things only there. One is related to depth and other one is what? So we are worried about two things related to groundwater. One is depth, other one quality. Like so many parameters, like what are the cations, what are the anions, what are the different you can say the parameters, almost like a big list will be there. Normally anybody make the groundwater. So like all those parameters 10, 11. So normally it is a sampling technique. You do the sampling and then you will measure. That is the groundwater things. So they all combinedly you are providing your own basin, that is we can call as an experimental basin, means everything is there. So all these things you can able to understand different process. Okay. So all the things only here what I am showing. So some of these things are all also important, like a sediment. So it is like a this is like a simple groundwater automatic manual, means like if you are, this is like a bore well or is a observation well. So they will just like a dump this one, like wherever the you can say the fluctuations in the water levels that will be recorded. Okay. So they only automatic you can say every day piezometer type of thing actually, the pressure those things you can get. So their quality means the sampling, that is we can't, but here we can get a piezometric you can say the pressure. So those things we can get. So here of course sediment is one of the things. Yesterday you are seeing, right, they are not only measuring that in the river basin level, right. There will take some actually the sample bottles will be there, samplers. So they will collect the even sediments that to sample water. So they will analyze for sediments, how much sediments are there. Okay. So they will frequently means for that gauge station whatever visited that is not there, but other places we will have that sediment sampler. So that they will go on select collect, and then they will do lab test, and they will find out what are the different like suspended solids, all things they will find out. That is also very important for so many studies. Of course soil moisture nowadays lysimeter, those things. So these are all like a very important field measurement instruments. So you can give from plot level. Plot means only one agricultural field to the you can say the basin. That way the all the instrumentation can be planned. Okay. So this is of course water quality I mentioned. So this all things whatever I explained, let they will come under the two broad categories. So it is like a whether you are doing a continuous measurement or it is like a intermittent measurement. Okay. So continuous measurement means what actually the here other day they are showing, right, whether it is a continuous or intermittent. So they continuously they will do, but it is like a time by time actually intermittent actually they are doing the you can say only daily twice like that they are doing, but they are continuously doing a thing, but not a continuous time scale like a rain gauge is there, you can't see the complete hydrograph, right, that type of things may not be there like whatever they are doing. For example automatic weather station, those things are there, we will get a continuous data set. So only thing is for the time we are dividing into different time levels, but we will get a continuous measurement. So now those are the two things. So depending upon the different type of problems, this type of whether you are going for a continuous or intermittent comes into picture. So this is like a in situ continuous measurement, these are all the case most of the times weather stations, all the things. So here intermittent means like a only velocity, hydraulic conductivity, those things will come. So intermittent means like hydraulic conductivity in this thing only few times you will collect actually. So most of other classes either a point or aerial. Most of the instruments go for a field means a point you will get. few only we will go for a aerial, especially the this type of, we can say drones, these things comes means they will come under the aerial platforms, aerial measurement will get. Okay. Now slowly shift is toward this aerial measurements. Only thing is some checks we can do with the field instruments. Okay. So now what is the current you can say thing? So current all the, you see, I think most of your systems you are seeing, right? So sensor based systems, automatic weather station, they are all like a sensors will be there, you can work with those things, and it is like a, for every sensor, like a, for example temperature, the one sensors will be there, temperature sensor, pressure sensors, like that. So every type of thing, so we can go for a one type of sensor type of equipment. Satellite based techniques. So even precipitation also we can get by the, you can say satellite systems, right? TRMM, so many missions are there right now to find out the rainfall will be based on the cloud, otherwise whether the rainfall is occurring, what is the amount of rainfall, the aerial based, we can get through the satellite techniques. Okay, it is one of the important things happening in these measurements. So here now this concept, like a interesting thing, this is like a open hardware. So what is this open hardware? This is one of the development in this sensing techniques, especially field based instrumentation. So what is this one, open hardware? So anyone we previously heard about this open hardware, like a open source software. So open source software, you know, right? So everything like a equivalent, like a, we have Word document is there, for example Microsoft, equivalent we have the other things will be there, right? Unix, Linux, one system will be there, Unix system. Linux is like a open source, right? Like a, that type of things are there, right? Same thing like a, so many softwares are there. So everything like a proprietary will be there, like only proprietary they are maintaining, licensing will be there. There is equivalent to lot of open source are available nowadays. Okay. So like a same thing like a concept for software, why can't we for hardware? That is the starting. So now like you see like a weather station, I say normally somebody will come, proprietary person will come, right? They will install the instrument. So we want the rainfall in one way, like a, for example every 5 minutes we want, every 10 minutes we want. So like that. But they have their own like a thing, and we want to see what is happening in the directly in the instrument and what is happening, and we want to see with us. But normally they have all instruments, right? They have their own software system will be there. That will go first there. Then they will send us. Only we are seeing in their domain actually. Okay? And means a lot of times we don't have a what is happening in the system. Whether really serving our some example, some specific research you are doing. So whatever the way they are, some commercial instrument is doing, that is not okay for you. You want to do separately. That you can't do with the proprietary hardware instruments. Okay, to solve all things now, it is like a same thing how we can apply for the this software, open software, that open hardware came into existence. Okay, so it is something like this actually. So it is like a, for example drone, you know, right, drones. So drones normally what they will do, they will like some commercial organ they are building. But now it's not required, right? You know, like all the components, if you can order like what are the things 5, 6 will be there. So you can take that one and you have your own thing and you can assemble and you can do that one. For that no, you can say so much, you can say the what technology, whatever, you need to have lot of things you need to know. So minimum things they will make according to the component and you can build. That's what I think. Same thing which is available in other systems like ECE and other domains, it is taken to the water resource thing also. That's what I want to tell you, field hydrology things. That's what I want to explain here. So this is all what I told right now, it is available. Open hardware means it's not nobody's proprietary. You can't say that some trademark like a source of company manufacture like that. Component wise you can take and you can build, you can assemble and you can use. Huh? LiDARs means that is like a, you can see like a, that much like a, like it is all like a depending upon the type of, we can say the technology is there. So much you can think means it's very difficult. Few things we can easily go for a open hardware. Okay. So that all like a, how the, I can say all the source code has to be available and the technology, the drawings, those things, sensors has to be there. So like a, so many other connected things have to be there. Then we can go for the, do that open hardware type of things. Okay. So here, the open hardware anybody say means that is like everything has to be available to anybody, they can work, and this all source file, especially code, anything like all the things has to be available to all the people. Okay. So it is like a, anything like it is not only somebody will do as per their requirement, right? If you know the other insights, anybody can do the anything like a development. That's what is the main thing. No, nothing but like a, somebody as a proprietor. Okay. So it's like a, this is what is the thing. It is like coming with a new way of developing the instrument, required instruments. Okay. So why that you can say we are so much interested in this open hardware? That's what I am saying here. Okay. So you can make tailor end, like what is the way you require the measurement, that way your instrument you develop. Like previously is like a whatever they are giving we have to use, right. We can change whatever the way you want, you can about accordingly you model, bring the instrument and then you can make. Okay. So it is like a, so you can make the software, everything is accessible to you right now, you can write your own code, see that directly it will come to model, especially forecasting type things. Instrument everything is in your control means you can easily model, right, you can easily do that one, that's what is the thing. So especially the cost actually, the you can say for example conventional rain gauge station, it is costing around near to 1 lakh automatic weather station. So if you are really able to survey, do market survey and then all things if you able to bring sensors everything, we can do within the half of the amount, that is possible, that things are possible. Okay, but of course you have to do lot of work you have to do and then you have to build that one. Yes, that all things once you are building means the first job is that only calibration and then checking the accuracy the things. So that's where other day we are visited right site. We also brought some instrument, you remember. So we want to check the, I can say that thing. Why we are checking there only? Since already CWC is doing right already some instrumentation, their data is there. Later we can calibrate. Otherwise, how we can calibrate our data set? Rain gauge you are being rain gauge for example you are building. You have to have some already existing rain gauge. You have to compare, calibrate, check. Then we can use. Okay. Otherwise, you need to do some lab scale thing study. First you do check, verify, then go for the field scale. Okay. So here so many you can say the things are there, like especially the who are doing, like you can ask like where I can get all these components. It's all like a very, I think if you are click this something you can get lot of, we can say the things like even now 3D printing they are saying, right. You want like something like you send something like I want this type of board, like where this circuit board you want, if you say means they will make for you as per your requirement and they will give by this 3D printing technique. So this is like I think most of you at least heard sometimes this Arduino. It's like now that that is the main thing in the open source hardware component. So you can get to this one and then whatever the this is like all microcontrollers. Whatever the way you want, you can collect and then you can use for your system. It's like a generic thing. So somebody want temperature sensor, so you can use this one Arduino. Somebody want rain gauge, somebody water level recording, somebody like only acoustic waves. Anything we can use a common Arduino will be there, we can use. Of course, this is like one more place where you can get these type of things. Okay, you can check and then sometimes you can really interest, like at least suppose some of you are the faculty are there, like you can give to students, like they can easily BTech students, right? They will feel nice to do this type of things. And a conventional modeling sometimes they may get very difficult things. Oh, okay. Oh, that's the thing. Okay, very good. So yeah, once means you can take from the open hardware, but for example you do right, you are where your own building, right, your own concept you are preparing means later you can take patent also. But if you do patent for your means that cannot be other people may not use, that thing will be there, that depending upon things. But whatever the already you are taken from open source, still that will be the open thing, like people can make use. So here some of the thing like actually the any especially for our field hydrology, anything will we are developing, the three components will be there main. One is sensor, second one is microcontroller. So sensor data has to be connected to microcontroller, right. So from microcontroller to software. So field to system, right, that's the where the how the instrument has to be there. So these are the three important components. So there is the one group of we can say the things, instruments, second group thing. So whenever you are developing thing means you have to look for these three setups. So you have to bring some hardware sensors. For temperature means temperature sensor you have to purchase. So control means like Arduino that have controller. Open source software means like you can see like there is a software with a micro Python like that, some tools are there, programming tools, tool box or tool setup that you have to use. Okay, some cloud you can say the open source visualization you can use. So with all things you can build complete your setup. Okay, so this hardware sensors they will be like normally the things which are collecting this environmental data set. So they are the main important things which will translate the data into the, I can say the from electrical signal to the digital data and then that they are sending. So this is like a sensor will take and sending to the instrument. So here So they will I can say main thing like they will work with like a lot of times like a one power system you have to be provide some electrical energy you have to provide to collect data. So that will collect that whatever data it is collecting, it will generate some signal that will be counted into some analog maybe number that will send to the microcontroller. Okay. So it's like a example is like these are all things like for example wind, this even rain gauge tipping bucket rain gauge like for example is there. We have in the market like for example anybody want like sensors for this one we will get. So like a similar like a wind this thing and you are saying like air quality, turbidity, so many are there available like that sensors. Okay. This is like a one tipping bucket rain gauge sensor that thing that whatever I am showing there. So that is like a some typical examples. Okay. They are all like a sensors. Okay. So you can just like ask this like a sensors, you first of all identify for the parameter you want to measure, see the sensors and then accordingly you purchase. Then microcontroller. So it is like a circuit actually, the data electric signal, right, it has to collect and then make into the digital value. This is the duty of this one actually. This is the exactly the act like the brain actually for the whole thing actually. So it is like all the things how much you can see you want to make it into the, these are all things Arduino, these are all the things available. So people nowadays like you see lot of things you will see when you are checking, these are all comes under that thing. It's one component. First connect data comes to this one. So this will go to, from this data will go to software. That's the thing. The third you see the component, these are all the different type of circuit boards or controllers. So they will act like a mini computer, it is you remember like that. So like they will do whatever you are doing in computer, right. So many things we connect to this thing, right, we will see all the things, how signal is coming, signal is changing, storing, everything we can see when you collect with the system. So here from the I can say we need to the I can say this is all like a transfer protocols actually. So sensor you are getting previous one, right. Previous one what you will get only in the control it will come, right. From there you need to go to the like the feed, there only you are collecting or you are sending to some place, other place. Then accordingly or your instrumentation will come, wired, wireless. For example, this system you want to see here, what you are doing somewhere in the field. From here to here you have either wireless or wired. So for example, telemetry is there means from that previous instrument is there, right. For example here. So this instrument we need to collect with the one more thing actually. So that is like a either SIM or the you can say other things. So that for that we need to have one more circuit board, small circuit board which can convert the data which is available in a these two we can say packets. Then only we can send through SIM, right. That thing we need to have one more circuit like it's like that. So you can see these things. There are like a different protocols for this one. So most times you don't need to much worry means there is like electrical you think that easy like that, right. We have to know something is required. Then accordingly you can try or you can ask some of your this thing where the people are there, they take suggestion accordingly you can use. Or nowadays lot of in everything they are providing data set like how you really can use. Okay, these are some of the things actually. So this is like a thing. So previous one is right. You need to have the additional connection of this one. So you see some place where we can keep the chip will be there. Sometimes Wi-Fi means no problem. Otherwise we have the chip to data to get to SIM actually. So that is like you see there is a location for the your you can say mobile this SIM card. Okay. So then last one is the software. So this is like a platform will be there like Arduino means Arduino platform will be there like other things are there. The data like I said like it is a computer, right. We need to visualize right what is happening in that particular data sets. But all things we can do here actually. So some C++ programming, Python, whatever the things, right, lot of things we can make. So whatever conventional programming you are doing same thing we can work here also. Okay. So we can do a lot of we can say libraries are available and we can try. Its duty is you have to see that from the sensor it is coming to the controller to the whatever the things finally to the system. That's what it will do exactly the things. Okay. So it is like a lot of things like one is like a commands means you want to do something error is there, you want to send a command from system to sensor that all things we can send. We can any storing you want we can make model. So like a time step you have to define right like a rainfall every 5 minutes you can do that programming here only. So every 5 minutes that packet whatever is coming you send to the sensor that we can tell. Okay. So it's all like a getting the data set. So here I said like we are also like working some of the I can say aspects like we can say the open hardware you can say components. So we are tried like with the rain gauge station. So then we are also like this is the one you can say the automatic weather station with some of these things. And this thing is like actually like we said like Sridharan, we are working with one Spark project which is related to the modeling. But the same Spark project, the main goal is to develop this one only. So the low cost open hardware watershed monitoring system that we are working. Like other day Hema one scholar she showing to you like all the with the one instrument we are trying to checking in the river. That's the thing only. Like we want to see the bathymetry, how we can do that one. Okay, this is all like a funding. Right now it is working with like right now how we work previously. The same we are working with one more city, that is a Tennessee University. We are trying that particular work. This is on way. It is ongoing work actually. It's a complete team actually who are working on that project. So it is like I said like previously also but this is all like a proprietary things like but same thing we are using for the how we do for our normal right now the instruments we are doing. Okay. So like right now hundreds and thousands of instruments are there, but who will do work make the database of all these things. Okay. And lot of anybody want to do the you can say this one like a storage, and then so all things are coming right, they have to come into one particular place and we have to visualize right. So for that India we have this one National Hydrology project. CWC duty is to collect, but to make a base or like how many gauge stations to increase, how many rain gauge stations you to keep. So everything they will monitor actually. This is like a now current actually. It is implementing in different phases. So now it is the second phase is going to start. First phase is already completed. That's why in the India right now we have a lot of measurement systems. Other day you are seeing right one software. First day India varies. One of the projects that developed under this India this National Hydrology project only. So this main goal is. Second phase already started actually. The you can say already it is commission means like a one. So they like all NRS they are all involved actually. I think even irrigation department is one of the what you call stakeholders in that whole things. State irrigation department, central, so all the things actually. So this is like it is all like to collect coming from different sources to maintain the data set. So this is like a World Bank is supporting this one entire thing. This is what I am saying like a second phase right now. Our first phase is all over. So it's all like a making every network modernize. Like other day you are seeing like a lot of instrumentation they are developing and they are going with the new concepts. This are all possible through this one only. So making more number of stations. So we have the more number of stations means more data you will get. More data means your simulation will be more correct. So more reliable. That way it will be useful for the forecasting and other things. Decision making is more easy. Okay. So it is like this is like three important organizations in India. I think this you have to know who are people who are really want to work. So things like one is Central Water Commission. This is already you saw the other day lot of things they are doing. Second one is IMD. This is all first day itself you tried and then we are seeing some of the things actually. So other one is more like a research. So some of you are there from the NIH, right? Who is there from NIH? So Institute of Hydrology you can say doing your project. I think that's yes. Internship you are gone to the Institute of Hydrology. I think some other also we are some people who are already connected with NIH. Yeah. Let's know the NIH. So they like a field scale you are saying right, lot of small experimental weather station they are maintaining, and all the testing, for example any model, whatever you model you say, they will have a lot of places for to testing and they will say that okay this is the reliable, these are the parameters, so many parameters list we will make right, they will make for the Indian basins. So here this is the NIH, this is basically the research, it is a collection and it is like IMD is related to mainly related to the climate parameters. They are related to the hydrologic parameters like what is the water levels, all the things. Okay. So the finally the summary is this like I said like, so it is very important like we will only bother about data, but always you have to see background how the where the data is originating and what happens. That's why we put intentionally that particular you can say the part in the our program, so that you have to feel that how things really happening in the ground level data collection. So that's like it will make us like a better understanding all our hydrologic process. So like they will make our more like a field hydrology or lot of you can say the we are getting. So it will take our hydrology like a further better, like we will come to know more intricate things which are there in the field scale. Then we can easily implement them in the models actually. So main thing is like maintaining those instruments itself is a very big challenge actually. So they say National Hydrology project like I am saying right. So they will make up to the budget available, they will very high end instrument they will purchase. then later maintaining is very difficult. Same thing happened for us also, like I told, right, we are installed some instrument in a nearby station, but where we can miss, like it is always like some 50 kilometers away. So we put the weather station, rain gauge station, and then all things. So like sometimes we told farmers to maintain, but later it got very difficult. And for example, that solar panel, people will took away that one actually. Solar panel means we can't get the remaining things. So flood come means that it will wash away that all things, nobody will bother. So that's where like a lot of maintenance is the main thing. It's initially will start, but especially this thing, somebody can able to maintain any like experimental weather station for so much time, experimental watershed. That itself is a great thing. So somebody like really any institute or those things, it is a very good thing actually. So that people later do lot of work with the data set. So of course like a lot of we can say the concept now. We will see data, but you see like the especially what unit that is giving. Sometimes like the other day you are seeing, right. So Qmex and Qsex. So like that lot of difference will be there when you are input in the SWAT model, other models actually. And what is the measurement they are using? Like what is the benchmark means what benchmark they are using? It is always important to understand those things also than only just looking at data and then go on working. Okay. Of course, like a lot of we can say thing like we can use the lot of we can say research with the repositories, but only thing is you see with something like some field observation also you include. Whatever you do research, do something field observation concept also is there. That is like make you more understanding the concept. Otherwise only we do SWAT model and we do this thing that may not make. So at least to visit watershed means that watershed you have to visit. So you are doing some simulation of the watersheds. You have to visit the watershed at least few times. So that is the means whatever I am planning. So let's open for discussion. Any questions?
Sir, is it a good idea to have instrumentation for a small watershed like watershed, 1 square kilometer, 2 square kilometer area, just to extrapolate the data to bigger watershed like 10 square kilometers?
Yeah, that type of things are there actually. I said like IIT Roorkee and especially the IIT Roorkee they are having that things. NIH. So there are like experimental plots, you can say plot scale to small you can say basins. So very small like 1 square kilometer, even half square kilometer, that type of things are there. Then only you can do like especially small things you want to construct in the basin and you can try those things. Even the Manning reference coefficient for example, you can't try on this thing, like you can try on the small things, how that really influence the flow. So things are possible.
Soil media will change, sir. Soil media will change from kilometer to kilometer.
That's why you less than half square kilometer you can have the field scale. Field itself is a one basin, like for example this room is there, water everything will go to one place means that is itself is a watershed. We can have lot of instrumentation there itself. Number of watersheds, small things. Yes. Any other questions? So for questions for you now. So why field instrumentation is important? Extreme events. So you need to like a lot of you can say design curves you have to prepare, right, like a 50-year flood, 30, 100 years flood. So thing means all those things how they will do with the field instrumentation only they will all have a lot of things and then connected things. Now this you have to tell. So what are the event based model if I say what is the important very important things parameters. Event based model for example rain like a flood event. Normally what is the field level what you have to measure? Discharge levels, rainfall, and one more important thing especially for event based model, temporal only, temporal like every minute 10 minutes like that you will get, but more important soil moisture, initial soil moisture, that is very important, otherwise you can't get the flash flood is coming. So that depend upon the how much soil moisture already there in the basin. So many times we will miss that one, so that we can't really simulate that peak we can say the flood or when the peak will come. That's very important actually. So virtual basis can we measure the you can say stream flow. Stream flow without instrumentation also I will from here itself I can see that how much water level is there. No instrumentation is possible. It's possible now with the satellites we have a separate you can say satellite systems. Other first day I mentioned actually. So there is separate group of satellites are there. We have even our ISRO is maintaining that one actually. So the day one I showed you that one the one thing actually we have the virtual you can say gauge they are called actually. Every time the satellite will come there that will give the you can say the depth measurements. It is a data you can get in the open source. Okay. It's reliable means like they will number of times they will get right, they will calibrate same with the gauge points and they will get actually. Yeah, it is there available that this one actually. Not reanalysis, it is observed. You can get, for example, you are getting the water level. Other day they are giving what is the finally you are getting level, right? This also will get the levels. Okay, that is like a from the you can say the satellite measurements you can get the levels. Like a sea level, like you will get right. Same thing like we will get the water level, water bodies level, you will get reservoir levels, you will get all things. In the Bunidhi and we have the separate you can see satellite systems which are only for doing for this first. Only the depth of water bodies measurements. Okay, that type of satellite systems are there. Exactly the satellite system exactly I could not recall now immediately. SWOT, SWOT that type of things are Indian. We have the one that satellite series is there. Only they will do that one. So not GRACE that exact satellite. First day it is there in slide. It is there. One slide also I gave for the how the virtually we can measure those things. So of course, what is the open hardware concept by this time I understood? Means no proprietor. There is nobody say that this is my instrument and I am the person actually. And how it is useful for our basins actually? Means we can make our own way, our simulation, our research work. Nobody is like as per data you are doing right now. The data everything you can plan accordingly what the way you require in your model. For example, you want a high each 5 minutes only you can train like that. 1 minute you want means you can plan like that also. That way you can do. Okay. So yeah, so this is the thing. So I will stop at this point, and yeah, that's all the thing. Lot of references we are like what are the things I provided to you. They're all from most of the sources. Lot of web sources about this open. Anybody really interested means it's a very interesting thing. You can see this one. You will get lot of information from these sources. So that's all from my side. So stop here. So we'll. So by 2:15. Once again we will go back to the you can see our lab at TLC, and then today is the basically we will see for a complete SWAT. That's what is the plan. So like as like most of the people it is useful. That's what we understood. So we will go that one. Okay. Yeah. So you want to announce? Yeah, yes, please. So that is the means whatever I am planned thing. So let's open for discussion. Any questions? Yeah, that type of things are there actually. I said like IIT Roorkee and especially the IIT Roorkee they are having that type of things. NIH. So there are like experimental plots you can say plot scale to small you can say basins. It's very small like 1 square kilometer even half square kilometer that type of things are there. Then only you can do like especially small things you want to construct in the basin and you can try those things. Even the Manning reference coefficient for example you can't try on this thing like you can try on the small things how that really influence the flow. So things are possible. That's why you less than half square kilometer you can have the field scale. Field itself is a one basin like for example this room is there, water everything will go to one place means that is itself is a watershed. We can have lot of instrumentation there itself. Number of watersheds, small things. Yes. Any other questions? So for questions for you now. So why field instrumentation is important? Extreme events. So you need to like a lot of you can say design curves you have to prepare right like a 50-year flood, 100 years flood. So thing means all those things how they will do with the field instrumentation only they will all have a lot of things and then connected things. Now this you have to tell. So what are the event based model if I say what is the important very important things parameters. Event based model for example rain like a flood event. Normally what is the field level what you have to measure? Discharge levels, rainfall, and one more important thing especially for event based model, temporal only, like every minute 10 minutes like that you will get, but more important soil moisture, initial soil moisture that is very important, otherwise you can't get the flash flood is coming. So that depend upon the how much soil moisture already there in the basin. So many times we will miss that one, so that we can't really simulate that peak, we can say the flood, or when the peak will come. That's very important actually. So virtual basis, can we measure the, you can say, the stream flow? Stream flow without instrumentation also, I will, from here itself I can see that how much water level is there. No instrumentation, is possible? It's possible now. The satellites, we have a separate, you can say, satellite systems. First day I mentioned actually. So there is separate group of satellites are there. We have even our ISRO is maintaining that one actually. So the day one I showed you that one, the one thing actually, we have the virtual, you can say, gauge they are called actually. Every time the satellite will come there, that will give the, you can say, the depth measurements. It is the data you can get in the open source. Okay. It's reliable means like they will, number of times they will get right, they will calibrate same with the gauge points and they will get actually. Yeah, it is there available that this one actually. Not reanalysis, it is observed. You can get, for example, you are getting the water level. Other day they are giving what finally you are getting level, right? This also will get the levels. Okay. That is like from the, you can say, the satellite measurements you can get the levels. Like a sea level like that you will get, right. Same thing like we will get the water level, water bodies level you will get, reservoir levels you will get, all things. In the Bunidi, and we have the separate you can see satellite systems which are only for doing for this first, only the depth of water bodies measurements. Okay. That type of satellite systems are there, exactly the satellite system exactly I could not recall now immediately. SWOT. SWAT, that type of things are Indian. We have the one that satellite series is there, only they will do that one. So not GRACE, that exact satellite. First day it is there, in slide it is there. One slide also I gave for the how the virtually we can measure those things. So of course, what is the open hardware concept by this time understood? Means no proprietor. Nobody say that this is my instrument and I am the person actually. And how it is useful for our basins actually? Means we can make our own way, our simulation, our research work. Nobody is like as per data you are doing right now. The data, everything you can plan accordingly what the way you require in your model. For example, you want a high, each 5 minutes only you can train like that. 1 minute you want means you can plan like that also. That way you can do. Okay. So yeah, so this is the thing. So I will stop at this point, and yeah, that's all. The thing. Lot of references we are like what are the things I provided to you. They're all from most of the sources. Lot of web sources about this open. Anybody real interest means it's a very interesting thing. You can see this one. You will get lot of information from these sources. So that's all from my side. So stop here. So we'll. So by 2:15. Once again we will go back to the, I can say, our lab at TLC, and then today is the basically we will see for a complete SWAT. That's what is the plan. So like as like most of the people it is useful, that's what we understood. So we will go that one. Okay. Yeah. So you want to announce? Yeah, yes, please.